Hi, welcome back. The problem today is about a radical equation. In the video today, I will show you how to solve this kind of equation, but also point out the method you usually met when you do this kind of equation. Give try before see my solution. Now, let's get started. Okay, we will have x multiplied by square root of 1 minus x equal to 1. And you will square both sides of this equation. This on the left it becomes 2x squared multiplied by 1 minus x equal to 1. Then obviously it will become the cubic equation, that is x power 3 minus x squared plus 1. And in this equation, you can find there's one real root. This is x equal to negative 0.7549, and the other two roots is the complex values. We put it out here. We just care about the real root, but the problem is when you replace these numbers into the equation, and this cannot be equal to 1. So where is the method you already did? The method is here. The step 2 you already did. You square both sides of the equation, but you did not care about the domain of x. So for this kind of equation that contain the radical side, you have to find the domain of x before you do any other actions. In this case, the domain of x should be under the radicals. You have 1 minus x. So because we consider the real root values, so 1 minus x have to be greater or equal to 0, then it means x is smaller or equal to 1. Okay, and another thing you would have to recognize that is this is non-negative numbers. This is non-negative numbers, and on the right hand side this is a positive number. This means x also have to be a non-negative numbers, because if x smaller than 0, this means the product of x and square root of 1 minus x would be a negative numbers. So x have to be greater or equal than 0. In conclusion, the square root the domain of x should be between 0 and 1. And when the domain of x between 0 and 1, after that you do this step, and in the final step you have the result is x equal to negative 0.7549, but this value is outside of the domain. Then we can conclude that there is no solution for this equation. So that's all. Thanks for watching. See you later. Bye.